So, don't forget to tell me to stop recording because last time we recorded for like 3.5 hours. Alright, so you guys should have a triangle on your paper. We're going to construct the centroid, and we're going to discover some interesting things about the centroid. Good. Let's try to make a 2 triangle again. Good. So this looks like it's pretty much a 2 triangle, right? Yeah. And so what the centroid is, that I can't write it?
Yeah.
I guess I could.
You can make it right in the place of the pen.
Yeah, with this? Oh, cool. Centroid. Wow, this is fun. The centroid is the points. I wish I could probably make it thinner too. Point of concurrency. Like this. I don't want to what is this? Point of undo it. Undo it here, right? So the centroid, I'm just going to say centroid is the median. Okay? Median. And so it's where all the medians intersect. Now you have to remember how to construct a median. For instance, I don't have, the way you have to do it is by doing the perpendicular bisectors. Do you remember how to do that? Okay. You put your compass here and here, and then you make these 2 marks that look like that. Got it? Okay. See, I can't show you how to.
Oh, wait, yeah, I know how to do that.
Okay. So let's see if I can draw on top of this thing. See, but then it's gonna. I can't because okay, let me try. See what happens. Something's gonna mess up. Right, okay, so where's my compass? That's why. What if I went back? So I can't really. So if I put my compass point on this point and this point, and I make, I'm gonna make some marks that look kind of like this. You know that little crossy things. And then you do a straight line through those 2 points. That's a straight line. Okay? And what you're doing, you're finding the midpoints of that. Okay? Let me do it on the board. So, but the way I can do it with Sketchpad is I can just click on here and I can construct midpoint. Okay? I don't even have to do it perpendicular by it. And then I'm going to do here, and I'm going to go construct midpoint. Midpoint. Oh, let me see that. Because I have too many things. So I'm going to construct the midpoint of these 2 sides. Construct midpoints. So now I have my 3 midpoints. But the median, it's not the perpendicular bisectors themselves, but it's the segment that goes from this vertex to any of those midpoints. So this, if I go from here to here, okay, and then from here to this midpoint, okay, and then from here to this midpoint, from here to that midpoint. And if you did it correctly, then they should all intersect at a specific.
Is it out?
That didn't work.
I have a question.
Hold on. They should all intersect at 1 point.
Wait, is it compass?
Okay?
You like put it on?
So, yes, ma'am.
Like I did for my median, I just drew a line all the way up.
Not done.
Like my median, like and they all intersect at the same spot.
Yeah, but that, no,
That's
that,
not it.
No, the mid, if you do the three,
So we're just finding the midpoint, we're not drawing a
yeah,
line.
yeah, the median is different than the perpendicular bisector. Perpendicular bisector is going to give you the circumcenter, right? The three medians, first you have to make the perpendicular bisector to find the midpoint, okay? Right? So you could actually, you know what you could do with your centroid? You found these midpoints, if you have the same triangle, you found these midpoints when you did the circumcenter, right? When you bisected each side. Yes. The centroid cannot be outside of the triangle. The circumcenter can be outside of the triangle. Because what you found was probably the yeah, you probably did the perpendicular bisector. So if I drag this triangle, notice that my centroid stays the centroid, okay? Doesn't move around, right? It stays. Isn't that cool? So if I connect the midpoints of all these sides, that centroid stays right there. And there's some unique things about the centroid, okay? Some unique things are, what's this do? How do I get a text box?
No. Way down.
There? Yeah. There's a way to get a text box.
But like, construct.
There we go. Wow. So now I can type in stuff. How do I do that?
Yeah.
Good. I go to here. I look for my typewriter. And then I go, whoa. And so then I could say that's the three medians. And it is also the center. Okay. Yeah, no, I can't. So what it is, it's the anyway, so what's unique about the centroid? It is the center of gravity, okay? So if I were to put my finger, okay, if I were to put my finger right here, that and this thing were made out of like steel or something, it would balance on that point. Or if I were to spin this thing around, that would be the point that I wanted to spin it around, okay? It's kind of like the center of balance, yeah, like that. The other thing that's unique about the centroid, watch, I'm going to show you this, okay? I'm going to measure the distance. I'm going to label some points, okay? There's a point, 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 okay? Now, say I want to measure the distance from A to B, okay? So I'm going to show you this. This has been a good thing to do in the lab over. A to B. And if I go measure distance, you see that? It's not highlighted,
Yeah.
so I have too many things. So measure distance, okay? I get that's 4.34. Now, I'm going to measure the distance from B to C. Measure distance, okay? Do you see a relationship? Oh, it adds up. Let's do another one. Okay, let's measure the distance from B to D. Okay? Measure distance. Okay? And then I'm going to go boom, boom, measure distance. Now do you see a relationship?
Yeah.
What's the relationship?
They all end with the same
No,
No.
you're gonna get the L.
BD is double.
Okay, watch. Okay, say I change this to exactly right around 4. Okay, let's do it even.
Yeah, I got it now.
Okay. What's true about the relationship between AC and this?
It's like BC is half of AB.
Very good. BC is half of AB, right? And BD is half of FD, right? And stuff like that. So then they'll say something like this. Okay, this side over here is EF is 3. What is this? Gotta be 6, right? And maybe they'll give you the whole length of the thing. Maybe they'll say that FD equals 12. FD equals 12. And they'll say find BD. How much would that be? 8. What you do is first you get 8, right? You divide it into 3s. And then so I would go 12 divided by 3. Okay? Which I get 4. So one thing has got to be 4 and the other one is 8. See? That's the way I do it. Okay? So that's what's important about this centroid, is where the 3 medians intersect and where the relationship is that this is twice this. Okay, wait, Emily. We need Star Trek. Good. There you go. And lastly, the very last thing that I'm going to show you, and this isn't going to be on a test or anything, but, we're done with this, kind of? Okay? The very last thing that I'm going to say is, I want a new piece of paper. New piece of paper. So, I want to get rid of it. If you have a triangle, let's make a triangle. So, here's a triangle. Kana, stay focused. I'm going to send this video to your parents with your name on it. So, what you have 1 point of the in-center, okay? You have 1 point called the orthocenter. You have 1 point called the centroid, and then you have another point called the let's call this the circumcenter, and this is called the centroid. Okay. What happens if you were to plot all 3 of those points? If it's an equilateral triangle, or all 4 of those points, if it's an equilateral triangle, all 4 of those points fall on the same spot. But if it's not an equilateral triangle, then 3 of those points lie on the same line. Okay? And the 3 points are, you're wondering what was special about the orthocenter? The only thing that is special about the orthocenter is that it lines up on this line. Okay? And that line has a name called the Euler line. And you spell that U-E-U-L-E-R, and Euler was a famous mathematician. And it turns out I didn't draw it correctly. The orthocenter, the circumcenter, and the centroid. So if you poke holes through your paper where all those points are, those 3 points, the orthocenter, the circumcenter, and the centroid, should all line up. And the other thing that's true is this is kind of like the centroid. I think it's this distance is 2 times this distance. I'm not sure if it's this is twice that or this is twice that. But that's something that's unique about all 3 of those points, the orthocenter, circumcenter, and the centroid, all line up on the Euler line, okay? Which is but the in-center is somewhere over here by itself. It's kind of lonely. But it's special because it's the point you use to inscribe a circle, you know? So it's got its own thing, you know? So anyway, we'll stop this cutting edge video right now. All right.